Previously, I discussed three key aspects of digital video: frame rate, resolution, and interlaced versus progressive scan video. If you have not already watched that video, I'd suggest doing so before proceeding. In this video, I want to discuss three more technical aspects which ultimately affect a video's file size and compatibility. These include data rates, codecs, and file formats. Let's first discuss data rates. Data rate refers to the amount of data per second a video requires to run. Generally speaking, higher the data rate, the better quality the video will be. Data rates are described in bits per second, or BPS. A bit is the smallest unit of measure when referring to digital data. You may have come across this terminology when discussing internet download speeds like 25 or 50 megabits per second, or Mbps. Video data rates are either described in kilobits per second or megabits per second and can be sorted into two categories: capture and output data rates. Capture data rate is the rate at which the camera records the data, while output data rate is the rate you output your final video as. First, let's focus on capture data rates. Some cameras will give you the option of choosing a capture data rate. Generally speaking, the higher the data rate, the better quality video you will capture, which will allow you to manipulate the footage, such as color correction, without degrading the video image as much as a lower quality video would. Values vary across different cameras, but it's common to see anything from 25 and 50 to 100 and 400 megabits per second options. If you're not going to color correct or heavily manipulate your footage, then choosing a lower megabits per second data rate will be fine. A good tip is to estimate the amount of recording time you will need and choose the highest quality setting that will give you enough memory space to store your video. In most cases, your camera may not even give you the option of choosing your own data rate, while some may even describe them using different terminology. This is where consulting the camera's manual comes in handy. Next, let's look at codecs. Codec is the name given to the technology that actually creates the video. So when you capture video, it does so using a particular codec which tells the video, among other things, what size it should be, how many frames per second it is, whether it's interlaced or progressive, and also its data rate. The codec that your camera uses will depend on its type. By far the most common is H.264, which allows for high quality video while maintaining manageable file sizes. A high-end camera, on the other hand, may use a codec like Apple ProRes because of its exceptional quality and high tolerance for color and other digital manipulation. However, this results in massive file sizes. A ProRes file filmed at 400 megabits per second will result in a file size of around 3 gigabytes per minute of footage. Choosing the codec you use for capturing your video will most likely be done by the camera and you won't have an option. Again, consulting the camera's manual will answer any questions you have about the codecs it uses. Codecs can't exist on their own. They need a container format or file format to live in. So this brings us to the final piece of the puzzle: file formats. File formats are the containers in which the codec and video lives in. They allow the video and codec to play back on devices like computers, phones, and televisions. Some file formats you may have come across include MP4, M4V, MOV, AVI, and WMV. Traditionally, these formats were developed by different parties to be used on a particular platform. For example, MOV and M4V on QuickTime or iTunes on a Macintosh, and AVI and WMV on Windows Media Player on a Windows machine. Nowadays though, most file formats will happily play on a Windows or a Mac. Much like with data rates and codecs, file formats can be divided into capture and output, and we will continue to focus on capture. There are a number of common capture file formats, including MOV, MP4, and something called AVC HD. Depending on the camera, you may or may not get an option to select which format you wish to use, and in some cases this will be determined by the data rate and/or resolution you select. So this decision could be made for you. It's important to note that your camera may give you the option of using MP4 or MOV as your file format, but they may still both use the same codec, like H.264. So it may come down to which format is more compatible with your computer, so it's best practice to do some tests before shooting. With higher end cameras like ones that shoot using Apple ProRes, only MOV files are available. So far, I've concentrated on the capture data rates, codecs, and file formats, the settings that can be changed before you begin shooting. But now I want to switch focus and talk about the changes you make to video once it's been imported and edited. What data rate, codec, and file format should you use when saving your video out in its final form? Settings will depend on where the final video will be utilized, as different media platforms like web, DVD, Blu-ray, television broadcast, and general computer playback will require different bit rates, codecs, and file formats. For the purpose of this video, I will assume the most common output: online video hosting. Without question, the most widely adopted way of outputting video is by using the H.264 codec in the MP4 format, with a data rate that is either recommended by the website in question or that you choose yourself. Depending on the software you're using, the output options will differ. For programs like iMovie, there are a number of options available, including exporting straight to YouTube or Vimeo, iTunes, or just a copy that will play back on your computer. More advanced programs like Adobe Premiere will give you almost limitless customizability of your video file, but also does have a nice range of easy-to-use presets. Video that is encoded at lower megabits per second values will result in a noticeable blocky and/or blurry appearance synonymous with heavily compressed low-quality video, as seen here at 1 megabits per second, compared to a high quality output of 16 megabits per second. For YouTube and Vimeo videos, between 8 and 16 megabits per second is recommended for full HD 1080p videos, while 4K should sit around 40 megabits per second. If in doubt, be sure to check with the target video hosting website for their recommended data rates. When exporting your videos, you will also have the option to change the frame rate, resolution, and whether it's progressive or interlaced. In most cases, you won't ever change the frame rate, and you will only need to worry about the interlacing if you are dealing with that kind of footage. It is, however, very common to change the resolution of the video, in other words, scale it down, from say 4K to 1080p, or from 1080p to 720, or really down to any size. This could be because the destination platform only supports certain video sizes. Or if you need to heavily compress your video, changing to a smaller video dimension can reduce compression blocking. On the other hand, it is never a good idea to scale video up, as this will result in a poor quality outcome. So to summarise, the data rate, codec, and file format you choose when capturing your footage will either be determined by what you need out of your shoot and what is required in the edit, that's if you have the ability to change those features in your camera, or for lower end cameras, it may come with standard settings that will be chosen for you. If you do have the option, aim for a file format that will work seamlessly with your computer and software, and a data rate that will allow you to fit all your footage on your memory cards. If storage is not a concern, then higher the better, as you will have more flexibility when doing heavy editing like color correction. When outputting your final video, a good, reliable codec is H.264 with the MP4 file format, and a data rate suited to the destination platform. One aspect of video I've purposely omitted is audio, which itself uses its own set of data rates and codecs. The reason for this is that in the vast majority of cases, as long as you capture clean, clear audio with enough volume, you won't really have to worry about the technical aspects. It really takes care of itself. Hopefully, the information in this and the previous video has helped you gain a better understanding about how digital video is created and will aid you in avoiding many of the common issues that can arise when shooting and exporting video.